All right, we're going to be looking at the lymphatic system as part of our immune system. Now, the lymphatic system is just a collection of blood vessels and organs that are going to move fluid and basically filter impurities and poisons and pathogens out of our blood. It's also going to help to maintain our fluid balance so that tissues don't swell up or dehydrate. Now, the lymphatic system, as you're looking at it here, here's how it works. Quick overview. At the tissues in the capillary beds, you've got the arteries and veins forming the capillaries, a little network between them. They're under pressure, remember. Under the arterial end, there's a whole lot of pressure, and it's forcing fluid, the plasma, out of the blood. And that plasma, once it leaves there, it's called intercellular fluid. And it's all out here throughout, in between all the cells, and it's picked up by the lymph, these lymphatic capillaries. And as it carries the lymph through the different vessels, getting larger and larger, they're going to pass through little filtering centers. So any bacteria that were forced out are going to be encountered, and you start your immune response. Now, the fluid cycle, remember, the lymphatic system is going to filter about 1 to 2 liters of fluid every day. It's pulling this out from between the cells and forcing it around. Now, some of the main lymphatic structures, if you're looking out here, you can see that there's not very many on this picture. It's basically vessels, like capillaries. They're the small ones that kind of go across here. Now, unlike blood capillaries are continuous between the arteries and veins. These are blind-ended, like a sock. The fluid just gets into it and only goes one direction. Okay? Those filtering centers are called lymph nodes. Now, the capillaries, as they pass through here with the lymph, they're going to pass through several lymph nodes before they get into larger vessels called collecting ducts and lymphatic trunks. Before that purified fluid is deposited back into the subclavian vein. And then it's sucked with the blood and mixed with the blood back through the heart chambers. And again, it's going to pass all the way through the body tissues, get forced out again, and goes back through, and is constantly being inspected for pathogens and other disease-causing organisms. Now, one other difference that you should notice between the lymphatic system and the circulatory system is this. The circulatory system has a pump, the heart, to force the fluid, the blood, all through the body. Notice here the lymphatic system, with all its capillaries and trunks and nodes and everything, has no pump. So the question is, how does this fluid move? Without a pump, the lymph is going to flow at really slow speeds, and it's under extremely low pressure, so it can't go very fast at all. So in this way, it's very similar to the veins, because remember, veins are extremely low pressure too. So all those mechanisms we talked about with circulation through veins apply here. Muscular contractions will milk the lymph back to through the nodes and eventually back to the bloodstream. So the skeletal muscle pumps, as well as the thoracic or respiratory pump, creating lower pressure inside your chest chamber. Your chest cavity is going to suck this lymph up. And just like in veins, valves are going to prevent the backflow. Remember, valves do not create pressure. They just keep it moving in one direction under low pressure. Now, unlike the veins, you have one other mechanism that kind of helps to bring lymph back up. And this is the speed at which the blood's flowing through the subclavian veins. As it's dropping in through there, it's dropping into the aorta very, very quickly by creating a suction from its force. If you've ever dealt with physics or even mechanics, the Venturis in a carbureted car work along the same way. As air moves through these two channels very quickly, it creates a suction that pulls gasoline around. Well, this suction is the movement of blood, creating a suction that pulls along the lymph as well. Now, if all those things are going to increase the flow of lymph, obviously it follows then that exercise is going to really speed up the return of lymph to the blood. Now, the lymphatic capillaries, where this all begins, as I said on the previous slide here, the lymphatic capillaries are blind-ended. Here's what I mean. In this diagram, right here, here is the end of the lymphatic capillary, kind of like the toes of a sock. All right? Now, what you've got here then is the spaces that are filled with fluid. Now, as this fluid pressure builds up, it pushes on mini valves in this wall. As that pressure builds up and pushes on these valves, fluid is sucked in to the vessels, and then all those mechanisms on the previous slide are going to cause that lymph to move along. On the right, you actually see one of the valves. You know, the lymph will flow this way, push this valve open, and enter into the lymphatic system as it passes through all the different vessels. You're going to have a whole lot of lymphatic capillaries leading into these lymph nodes, and they are called afferent lymphatic vessels. The prefix affer, A-F-F-E-R, always means toward. You're going to have only one efferent vessel carrying fluid away. Again, efferent, E-F-F-E-R, means away from. So here's what's happening. You've got a whole bunch of incoming fluid into one lymph node. You've got a whole bunch of blind ends and one-way streets and dead ends for this fluid to move through to get to this. So as this fluid goes through here under low pressure, so it's not going to move really fast, it's going to be mugged, basically. Think about it like this. This lymph is carrying pathogens or disease-causing organisms. As it goes around these corners and everything, it's going to encounter macrophages and other disease-fighting cells that are going to destroy those pathogens. So when the blood or the fluid leaves here, it's going to be relatively clean. And this efferent vessel will lead to another lymph node, and when it gets closer, they're going to change the name to afferent vessel. So you might see these things pass through 2 or 3 lymph nodes before they end up going back into circulation. Now, what happens when this flow is interrupted? In some third world countries, this is a common problem with a certain parasitic worm. Here's what happens when the lymph nodes or the lymph vessels are blocked by these small parasitic worms. They take up residence inside there and they block the return of lymph. It's called elephantiasis because the people's skin takes on a really rough texture, kind of like an elephant's hide, and not to mention the size. This is all swelling. All that intercellular fluid has built up and is pushing out on the skin. And this is one of the more tasteful pictures I could put up here. Some lymphatic tissue you guys are aware of. Just mention a few of the organs here. Obviously, tonsils. Tonsils are covered by epithelium, and you've got tonsils in your throat. You've got the palatine tonsils, with the back side of your mouth cavity. These are the ones that are most commonly infected. You got the lingual tonsils underneath the tongue, and you got the pharyngeal tonsils or adenoids way back in the pharynx. Bottom line is this. This is one of your first lines of defense against infection that might try to come in through your mouth. Okay, so if you go out and clean a carrot and eat a raw carrot, all right, there's still some bacteria on there. This is one line of defense. So anytime they would encounter any kind of bacteria, they become trapped in these crypts, or their tiny blind dead ends. Now the thymus is another lymphatic structure. It's really closely tied to your immune system, mostly because this structure is going to be where the special type of B cells called T cells, T lymphocytes are formed, or matured anyway. They are formed in the bone marrow, but they travel to the thymus to mature. What you see on here is a picture on the left is the picture of a child's thymus. Over here on the right, a picture of an adult thymus. The thymus is one of the few organs that will shrink with age. The older you get, the smaller it gets. And this is another organ here where fluid will pass through and encounter pathogens. But again, more importantly, this is the place where T cells will mature. I always describe this as school for T cells. More about that when we do our endocrine system, our immune system. Finally, the spleen is classified as a lymphatic structure here. Okay, basically its functions are for red blood cell production in infants. And we mentioned before with red blood cell disposal. But again, it also, besides filtering out damaged and destroyed red blood cells, it will inspect it for other pathogens. Although its function there is not nearly as great as it is with the lymph nodes, it does have a small role in fighting off pathogens.